Hi, Algebra 2. We are starting off our Unit 6, and we're on the first day. It is all about simplifying radicals. You have simplified radicals before in Algebra 1, also probably in 8th grade math, but we are going to start by reviewing this because we need to know how to simplify a radical in order to do other operations with radicals. So when we start like adding, subtracting, multiplying, dividing radicals, we're going to need to know how to simplify them, all right? So first off, we have to make sure we understand what a radical actually is. So when you guys see this symbol, it looks kind of like a division line, but with the extra little marking there, that is a radical. And you're talking, usually we look at square roots. This is the sign, the radical sign. The index just means what root you're taking. So if it's a square root, usually it means a 2. So for example, if I wanted to, excuse me one second. Okay, so for example, if I had the square root of, let's say 9, that means really there's a little 2 here, because what that means is I'm looking for two numbers that multiply by itself, well, one number that multiplies by itself 2 times. So for example, my one number would be 3, but it multiplies by itself twice, and that gives me the 9. So 3 squared makes 9. Whereas the square root of 9 makes 3, okay? So they don't equal each other there, but 3 times 3 equals that. So if I took the square root of each of these, the square root of 3 times 3, or the square root of 3 squared, or the square root of 9, what you wind up getting is just the root, which is where does that 9 come from? It comes from 3 being multiplied by itself twice, basically. For example, if I took square root of, let's do 8, and instead of a 2, let's put a 3 here. So now my index, this little number that's being represented by n, that index is now 3. So what number multiplied by itself 3 times would make 8? And if I just think about 8 as an even number, I can break down 8 into 2 times 4, which really, if it's 2 times 4, 4 can be broken down into 2 times 2. So now I get 2 times 2 times 2 makes 8, which is really 2 cubed. So if I took the square root, because remember, right now we're just breaking down 8, so it's still underneath this radical sign. The radical sign is asking you, what is the root? Where does the 8 come from? And it comes from the 2 being multiplied by itself 3 times. So this little index number right here that we're looking at, that number tells you how many of the roots do I need in order to get the number that's underneath the radical sign, all right? So if we take a look at this, the first example, simplify 25x squared. There is no number here. If there's no number here, we automatically assume that it is a 2. Go ahead and take a second to write down both examples. If you need to pause the video. If you feel pretty comfortable with this, if you remember it from Algebra 1, go ahead and try it on your own. Otherwise, I'm going to go ahead and break down the square root of 25. So I know that 5 times 5 makes 25. And then I also know that x times x is x squared. So really 25x squared is 5xx, the product of those. If I want to take the square root, what I'm asking for is, well, I need 2 of them. So here, 2 of these 5s, the product of 2 5s makes 25. So 25 comes from the root is just the 5. 5 is the number that I use. It's the root that I use in order to make 25. So if I have 2 of the same item underneath a square root, then really I'm just taking out 1 to represent my root. All right, same deal here. Let's do a little bit faster here. So I know 100, again, I'm looking at an index of 2 because there's no number there. If there's no number, it's always a square root, so it always means 2. Square root of 100 makes 10. 10 is my root because 10 2 times, so if you use this 2, makes 100. A squared. Well, how many a's make a squared? 2 of them. So my root is 1a. And then how many b's make b squared? 1 of them. So 1b is my root. All right? So the square root of 100 a squared b squared makes 10 with 1a, 1b. In other words, if you want to check your work, I can take 10ab, and because it's a square root, I can take 10ab and multiply it by itself twice. So I'll do 10ab again. And what I should wind up with is what is underneath the radical. So 10 times 10 makes 100. A times a makes the a squared. And then b times b makes the b squared, which I do. So I have done that correctly. Very nice. Let's try a few more. All right, these are all square roots. Since we're talking about square roots, it'd be nice if they were perfect squares. So if you think back for a minute, a perfect square is, I know we talked about this a little bit at the beginning of the year as well, and we've heard it several times. However, a perfect square is a number that multiplies by itself, right, to make a larger number. So if you have that larger number and there are two roots, there's a root that multiplies by itself once, we wind up getting that perfect square. But it has to be even. We can't have any leftovers. So for example, 25 that we were just talking about, 25 is made out of a product of two fives. 5 times 5 makes 25. No leftovers. So 9 is another example, right? 3 times 3 makes 9. 4. 2 times 2 makes 4. 1 times 1 makes 1. Let's talk about 4 times 4, 16. 5 times 5 we have. 6 times 6, 36. 7 times 7, 49. Oopsie. Let's grab the eraser. 8 times 8. Let's see. There we go. 8 times 8 makes 64. So I'm just making a little list here of the different numbers that are making perfect squares. So 64 is another one. 9 times 9 is 81. And 10 times 10 is 100. 11 times 11, 121. And then 12 times 12, 144. And that's really, those are the ones that we should be pretty familiar with. Any higher than that, let's see, 12 times 12. 13 times 13 is 169. This is just knowing our multiplication tables. There we go. So when I look at 8, 8 is not a perfect square. So we might have some remainders here. So 8 can be broken down into 3 2s. We did that on the other page. 2 times 2 times 2 makes 8. Since we're looking for a square root, we're really just looking for 2 of a kind. If this extra 2 wasn't here, I would have a perfect square because it would be 4, right? So 2 times 2 makes 4, but I need this extra 2 in order to make the 8, to make the whole radicand, the whole number underneath the radical. So I know that the square root of 4 is 2, so I can write down 2. But I have this remainder. I have a leftover that is helping me make the 8 that I need. So I need to keep the leftover inside the radical because it is not a perfect square. All right, so the remainder 2 stays inside. I get to pull this 2 out though because this comes from the 4. 2 times 2 is 4, and square root of 4 is 2. So if I see 2 of a kind, I can pull it to the outside. Same on this one. 16. Well, 16 is a perfect square. It's right here. So 16 comes from 4 times 4. X cubed is 3x's. All right, so since I'm looking for, again, this number, the index is still a 2, so I'm still looking for a square root. I'm looking for 2 of a kind. 4 times 4 is 16. That's a perfect square, so I can take the root out. I have 2 x's. X times x, x squared, that's a perfect square as well, so I can take the root out. And then I have this leftover. Leftover has to stay on the inside. All right? Everything on the outside here, everything's multiplying by each other. So if I could simplify the numbers on the outside, I would. 4 times x, though, I can't do anything else with that. This is considered separate. Whatever's on the inside of the radical has to stay separate. And let's see, square root of 27. So 27 comes from 9 times 3. A squared, I'm going to leave it as a squared for a minute so you guys can see what's happening. B cubed, that's 3b's, right? All right, all of those are multiplying. Remember, b times b times b times a squared times 3 times 9. All right, if I look at this 9, 9 is a perfect square, right? 3 times 3 makes 9. So square root of 9 is 3. I can pull that out. So now I don't have to worry about the 9 anymore. 3 I can't do anything with. That's not a perfect square. That's going to have to stay on the inside of the radical as a leftover. All right? A squared is a perfect square because this means there are 2 a's. So I can pull the root out. So now I'm done with all 3 of those. I've already talked about them. And then I have 3 b's. Well, 2 of them, b squared, these two, is the same thing as a squared, right? b times b squared, same thing as another variable squared. That means I can take one of them out as the root, but there's a leftover. So I'm going to have a b that's left over on the inside. So you are looking at how many of each there are. There are 2 a's, so I can pull one out. There are 3 b's, so I can pull one out, but I'm going to have a leftover on the inside. And let's go ahead and break down 32. 32, let's see, half of 32, I know it's an even number, so half of 32 is 16, so 16 times 2 makes 32. I have 1x, won't be able to do anything with that, and then I have 5 b's. Instead of writing out all 5, I'm going to write them in pairs of 2, because I still have this index of 2 here. So I have a b squared, that's 2 b's, another b squared is 4 b's, I'm supposed to have 5. There we go. So let's see, square root of 16, that's a perfect square, so that would be 4. And then, let me draw a little line here so I don't get confused. Okay, so that means I have a 2 left over on the inside. So those are both done. I have 1x, I can't do anything with 1x, so that's going to have to stay on the inside. I've got 2b squared, so that means the root comes from, for b squared, I can pull one of them out. I have another b squared, so I can pull another one out. And I've got a leftover b, so that's going to have to stay on the inside. Okay? Whatever I have, well, for my answer, I want to simplify. So I have 4. 2 b's multiplied would make b squared. And then I still have a 2, an x, and a b left over on the inside. Okay. Let's see what else we've got. So now let's think about perfect cubes. All right, if 1 times 1 makes 1, that's a perfect square. Well, 1 times 1 times 1, 3 times, still will make 1, so I can keep that. All right, how about 2 though? If I multiply it 3 times, 2 times 2 times 2 is going to make 8. And 3 times 3 times 3 will make, so 3 times 3 is 9, times 3 is 27. 4 times 4 times 4, so 4 times 4 makes 16. Times another 4 will make 64. And then another one we should know is also 5 times 5 times 5. That will make 25, and then times another 5, that will make 125. So 125, 64, 27, 8, and 1. Those are all perfect cubes because 3 of the same number will multiply to make them. So I'm going to do this the exact same way. The only difference is I'm going to see this 3 right here. That means I'm looking for 3 of a kind. So a cube root instead of a square root. I'm still going to break down 27 into 3 3's, and I see that that is one of my perfect cubes right there. And then I also have 3 x's. All right, I'll only do this once. We don't have to write this out every single time. If I have 3 3's, that means I have 3 of a kind, and I know that makes 27. So 1 3 is the root for making 27, because if I have 3 of them, I'm making 27. So if I have 3 of a kind, 1 can come out to represent it. Same thing with the x's. I have 3 of a kind, so the x can come out. I have nothing left over, so I have no root when I'm done. Don't have any remainders. Same deal with 16. 16, cube root, excuse me. I make sure I have the 3 here, otherwise it'll look like a square root. 16 comes from 8 times 2. And if you notice, guys, 8 is a cube root. So that means the cube root of 8 is 2. That was where it came from, right? 3 2's made 8. So I'm done with that one. But I have a 2 left over, so I'm going to have to keep my 2 on the inside of my cube root. Remember, you got to put the 3 there. If you don't put anything there, it looks like a square root. And then last but not least, I'm going to look at the cube root of 5a's, a to the 5th. That means I have a times a times a times a times a. So I have a. I got 5 a's there. Again, I'm looking for 3 of a kind. I can only do that once, and then I'm going to have 2 left over. So I'm going to pull out 1a to represent these 3, and then I'm going to put my other 2 that are left inside. And again, this is a cube root, so I have to keep that 3 there. I'm going to go ahead and fill these out. Push pause, and when you guys push play again, go ahead and write these down. Push pause, try them, and then when you push play again, you can check your answers. I will see you guys next class.